Welcome to Creative World. In this video, we will solve Chapter 3 Learning Assessment E3.21. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node is always equal to 0. Sum of all entering currents on a node inside an electrical network is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Learning assessment E3.21. Use nodal analysis to solve the network in example 3.15 and compare the time and effort involved in two solution techniques. This is the circuit diagram of given problem. You may refer the book to see example 3.15. In example 3.15, this scenario is solved using mesh analysis technique, and in this scenario it is asked to solve the same problem using node analysis technique. So without wasting time, let's proceed towards the solution. We know that in order to apply nodal analysis on any network, we have to follow some steps. The first step is to label all node voltages in the network. In this network, there are 4 number of nodes. Out of 4, one is reference or ground node. Other 3 nodes are taken as V1, V2 and V3. In next step, we have to assume and label all branch currents along with their directions. Now, in order to calculate the value of V0, we should have the value of current through this 6 kilo ohm resistance. Or in other words, if we know the value of voltage V1, which is taken with reference of this ground node, we will be able to calculate voltage across these two terminals labeled as V0, and we are interested to calculate their value. So we can say that whatever the value of voltage V1 will be, this same value will also be equal to V0. So we are interested to calculate the value of V1. For that purpose, we will apply Kirchoff's current law on these nodes. So first of all, we will apply Kirchoff's current law on this node. On this node, only one current is entering, that is I3, while two currents are leaving, I1 and I2. Leaving currents are taken with negative sign and entering current is taken with positive sign. In next step, we have to replace these currents with their respective equations. Current I3 is equal to 4 mA because of same branch and same direction, while current I1 is equal to voltage difference across this 6 kilo ohm resistance divided by the value of resistance. On this node, voltage V1 is appearing and here minus 3 volt is appearing. Because the direction of current is downward, it means this voltage is considered higher than this minus 3 voltage. So the difference of these two voltages will be taken in this term, that this voltage will be subtracted from V1. So equation of current I1 will become V1 minus into minus 3 divided by 6 kilo ohm. Next, current I2 will be equal to V1 minus V2 divided by 2 kilo ohm. Now solve this equation, multiply on both sides with 6 kilo ohm. The equation will become 6 kilo ohm and 4 milliampere will become 24 volt minus V into plus 3 volt. This minus is multiplied with minus outside of the bracket. It will become plus 3 volt. Minus 3 into V1 minus V2. Here the product of 6 kilo ohm will cancel out with 2 kilo ohm in denominator. Only 3 will left, and that 3 will be multiplied with V1 minus V2. Now open these brackets. This minus will multiply variables inside the brackets and place this constant value on the other hand side of equal. The equation will become minus V1 minus 3V minus 3V1 plus 3V2 equal to minus 24. Now place this minus 3V on the other hand side of equal and add values having same variables together. The equation will become minus 4V1 plus 3V2 equal to minus 24 plus 3. Add minus 24 and 3 together. The equation will become minus 4v1 plus 3v2 equal to minus 21. Now we cannot further solve this equation, so we will leave it for now and label it as equation A. It is the first node voltage equation of this network. Next, we will apply Kirchoff's current law on this node. On this node, two currents are entering, I2 and I4, while only one current is leaving, I5. So Kirchoff's current law equation for this node will be I2 plus I4 minus I5 equal to 0. Now replace these currents with their respective equations. I2 will be equal to V1 minus V2 divided by 2 kilo ohm. I4 will be equal to V3 minus V2 divided by 4 kilo ohm, and I5 will be equal to V2 divided by 4 kilo ohm. In order to omit denominator values, multiply this equation on both sides with 4 kilo ohm. Here the product of 4 kilo ohm will cancel out with 2 kilo ohm, only 2 will left, and that 2 will be multiplied with nominator values. It will become 2V1 minus 2V2. Here product of 4 kilo ohm and 4 kilo ohm in denominator will cancel out with each other, only V3 minus V2 will left. Here also 4 kilo ohm will cancel out with 4 kilo ohm in denominator, only V2 will left. Now arrange the equation and add values having same variables together. The equation will become 2V1 minus 4V2 plus V3 equal to 0. It is the second node voltage equation of this network. Now apply Kirchoff's current law on this third node. On this node, all currents are leaving, I3, I4 and I6. So Kirchoff's current law equation for this node will be minus I3, minus I6 and minus I4. Now replace these currents with their respective values. Current I3 will be equal to 4 milliampere and current I6 will be equal to 2 milliampere, while current I4 will be equal to V3 minus V2 divided by 4 kilo ohm. Now in order to omit denominator values, we will multiply this equation on both sides with 4 kilo ohm. Product of 4 kilo ohm and 4 milliampere will result 16 volt. Similarly, product of 4 kilo ohm and 2 milliampere will become 8 volt. Here product of 4 kilo ohm and 4 kilo ohm in denominator will cancel out with each other, only V3 minus V2 will left. Now open these brackets, this minus will multiply with values inside the brackets. The equation will become minus 8 and minus 16 will become minus 24 volt minus V3 plus V2. Now place this minus 24 volt on the other hand side of equal. So the equation will become V2 minus V3 equal to 24 volt. And it is the third node voltage equation of this network. Up to this point, we have found three node voltage equations of this network, which are listed here as equation A, B and C. Now we will solve these equations to calculate the value of voltage V1. So first of all, we will multiply this equation B with 2. The equation will become 4V1 minus 8V2 plus 2V3 equal to 0, and the resulting equation will be added into equation A. This minus 4V1 and plus 4V1 will cancel out with each other. Sum of 3V2 and minus 8V2 will become minus 5V2 plus 2V3 equal to minus 21. Now we will take this resulting equation as it is and multiply this equation C with 5 and add that resulting equation into this equation. Product of 5 with this equation will become 5V2 minus 5V3 equal to 120. Now add this resulting equation into previous equation. This minus 5V2 and plus 5V2 will cancel out with each other. Minus 5V3 plus 2V3 will become minus 3V3, and on the other hand side of equal, 120 minus 21 will result 99. Now in order to calculate the value of V3, divide on both sides with minus 3. the value of V3 will become minus 33 volt. After calculating the value of V3, we are able to calculate the value of V2 by replacing the value of V3 inside this equation C. So V3 equal to minus 33 volt and replace V3 inside this equation C with its value. The equation will become V2 minus into minus 33 volt equal to 24 volt. Now open this bracket, it will multiply minus outside of the bracket, both minus will become plus. The equation will become V2 plus 33 volt equal to 24 volt. Now place 33 volt on the other hand side of equal to calculate the value of V2, that will become minus 9 volt. After calculating the value of V2 and V3, we are able to calculate the value of V1 as well. So we have replaced the values of V2 and V3 inside this equation B. V2 is replaced with minus 9 volt and V3 is replaced with minus 33 volt. Now open these brackets, product of minus 4 and minus 9 will become plus 36. Similarly, this minus will multiply plus outside of the bracket, it will become minus 33 volt. Now subtract 33 volt from 36 volt, it will become plus 3 volt and place this constant on the other hand side of equal. Again it will become minus 3 volt. In order to calculate the value of V1, divide on both sides with 2. So the value of V1 will become minus 1.5. And as we discussed earlier, V1 will be equal to V0 because of parallel connection. So we can say that the value of voltage V0 inside this network is also minus 1.5 volt. As we discussed in our previous learning assessment E3.20, there are multiple solution techniques exist to solve complex electrical circuit problems. But the selection of right technique might save our time and effort to solve the problems. In example 3.15, this same problem is solved using mesh analysis technique and within few steps the problem is solved. But using nodal analysis technique on same problem took too much effort and time to solve it. So this was learning assessment E3.21. Thank you. See you again in next video.